Alright, so we're going to take a look at most missed problem number 15. This one deals with quotient rule again, but this time it is analytic. It's not with a table of values. So if I look at this one, it says g of x equals sine x over the square root of x. So we're going to go ahead and apply the chain rule. So we have g prime of x. It's going to equal low, so root x. Then we're going to take the derivative of high, and I'm going to show an extra step here just for clarity. So I'm going to write that we still need to take the derivative of that high function sine x minus high d low all over low squared. Now in practice, many of us won't take this step, but again it's just to show that really the structure takes me to here, and now I have these two derivatives that I have to go ahead and evaluate. So in the first one I've got root x, and that first section of blue, derivative of sine is cosine. So we have root x cosine x minus then the sine x, and now we have derivative of square root of x. So we can either use a power rule and write it as x to the 1/2 and the derivative would be 1/2 x to the negative 1/2, or we can remember it as a rule where that becomes 1 over 2 root x. Alright, this one will come up enough that it's almost worth memorizing as a rule there. Alright, from here I've got square root of x squared. That is just going to be x as we go through. Alright, and technically that's always going to be positive. So I'm going to put an absolute value on it for right now, and we'll see if we need that when we get towards the tail end of the question. So there was originally a domain restriction on this that x was greater than 0. Otherwise the square root of x wouldn't be defined, which makes me feel like we shouldn't need the absolute value, but technically there when we reduce that, we would have had a positive for sure. Alright, but again the domain restriction would tell us that we can leave that off because x is greater than or equal to 0. So I've got root x cosine x minus sine x over 2 root x all over x. Alright, so I'm going to clear the complex fraction by multiplying by 2 root x, top and bottom. Alright, and when I do that, up here on top, I get 2x cosine x. Alright, and again, we don't have to worry about the absolute value there because of the fact that our domain is restricted to x greater than 0. Alright, minus the 2 root x is going to cancel here, so we have sine x. And that's all over 2x root x. Alright, would be one way we could write it. We could also push it together into one piece. I looked to see if anything simplifies. It really doesn't. So I would probably go here as my final answer. You may find Khan wants you to go ahead just a little bit further. Alright, nothing dramatic. But take that x times square root of x and write it as 2 root x cubed. Alright, if you're not sure where that came from, try and simplify 2 root x cubed, and you'll end up right back at that 2x root x. So that's the approach to this problem. Again, the hardest part on this one is really the algebra. The calculus involved is truly done after that step. From that step on, it's algebra, and then the frustrations of trying to match formatting with what the computer is looking for. That gets easier over time, but it is a tough one here at the beginning. Alright, hope that helps.